Fantastic. Let's get started. So, good morning, good afternoon, good evening to all of you who have joined, and a very warm welcome from all of us here at Encord. Excited to be presenting today's webinar on how to speedrun your AI data pipelines with all of the latest foundation models. I'm Oscar. I'm one of the solutions engineers here from Encord, and so I spend my days speaking with customers and learning about their use cases. And we're very lucky to be joined today by Fred, who's the head of our AI team. Fred, would you like to do a quick intro to yourself?
Yeah, of course. Hi, I'm Fred. I'm the leading machine learning engineer, and I've spent a lot of time looking at both generative models and a lot of data wrangling. And I've definitely felt the pain of having to move data around, having to get it in the right shape for training one or two or many more models. So yeah, this is one of these topics that are really dear to my heart, and I'm very excited to get started today.
Fantastic. So what do we have in store? So the future of AI is multimodal. And so when we are thinking about the processes that we have in place for building our data sets for AI, these are not sufficient as we increase in complexity and across modalities. And so we're going to be discussing what these pipelines look like today, and then what they need to look like in the future in order to achieve these multimodal AI functions. And then we'll be presenting the new Encord data agents and how they can help solve this problem. And Fred's going to give us a live example of how we could go about building a multimodal video data set for a GenAI application, which is very exciting. And for those of you who are not familiar with Encord, we are a data development platform. And what that means is that we provide everything from management and curation of all of your different data, sending this through for annotation and how we can kind of scale these workflows using various different semi-automation and automated tooling, and easily distribute this to our teams. And then finally, model evaluation and evaluating across our data where our models are successful or where they fail as well. And the key with these is that we want to move from left to right as fast as possible. And that's what we're here to talk about today. So
yeah,
without
the
further
truth
ado,
is really right, Oscar. The truth is really you need to do that many times, right?
So, oh yeah,
the faster you can do it, the more times you get to do it. Yeah,
big time, big time. So when we're thinking about multimodal AI, we can see a bunch of cool use cases here, right? And a bunch of inputs and a bunch of interesting outputs. But Fred, can you set the scene? From your experience, what does building these data sets look like?
Yeah, definitely. Yeah, I'm actually going to start a bit down memory lane, I think. So I remember when I did my machine learning 101, we would get a data set of a bunch of images. Every image would have a label telling whether it was an image of a 1 or a 2 or a 9. And then we were training a CNN to actually predict what the number was on that tiny little 28 by 28 pixels image. And of course, the reality today is much, much different. As you said, we have all these different use cases where they're just like so complex by nature. For instance, voice AI or physical AI, where you're trying to, train a model to control a, robot arm with 40 motors, and you're doing it from vision and from language, and there's just so much stuff going on, right? And the complexity is so high that the problem of actually getting the right data has just become harder and harder for every time the complexity of these problems has increased. And all these cool things we see here in the middle are sort of good testaments to that. The same goes for generative AI, right? Where you want to, have some sort of model that can generate text or videos or images or proteins or whatever it is. And really the key here is that we have to leverage all the stuff we have, all the problems we have solved already. And we have to stand on the shoulders of all the hard work that has happened already. And that's essentially what we're gonna see today, how you can actually do that. And of course, to make that maybe a bit more concrete, this means we know how to find people in images, or how to tell what number it is on the image. So there's no reason to sort of reinvent that wheel, at least. So we might as well, build a car on top of it instead.
Yeah, it's a great point. So as we want to solve harder problems, we need to be able to incorporate more data. And to incorporate more data, we can't just rely on the old way of doing it, because the kind of orders of magnitude have increased so much. So we need to be able to kind of scale this approach so that we can iterate faster, which I think leads us nicely onto our next slide, which is a quote from an esteemed member of the AI community, yourself, Fred. So do you want to talk us through it?
Yes, for sure. So I'm almost just going to read it out loud. So if you want to get to state-of-the-art model performance, or even good enough, right, it requires a lot of iterations. It's not like you just have the data, you label it, and you train your model, and then you're done. It requires a lot of iterations. And this process of iterating, it can be very fun and very efficient, but it can also be laborious and soul-crushing. And the difference really lies in how fast you can iterate. I'm going to give just like one example. Right? Imagine you are about to solve a very big problem. And so you collect a lot of data and you send it to an annotation team somewhere, or maybe you start yourself annotating all your data with human labor. And then half a year goes by, and then finally your data comes back and it's ready for training. And then you start training, and then the thing just doesn't work. And you realize that there's some little nuanced point that just breaks the entire thing. And now your soul is crushed, right? Because you have to go back and do the same thing again. One more extent of like 6 months, just, yeah, it's gonna hurt. On the other hand, if you could have done something in, let's say, 2 weeks, and then you could have trained your first model and already learned this particular little nuanced point that you didn't really realize in the beginning, then you just saved, I guess, 24 weeks, right? And you can iterate 13 times within that half a year. And I bet you're going to have a better model than you would ever get by waiting 6 months, right? And then it becomes fun, because then it becomes this sort of bug hunt and iterative improvement thing that is a lot more fun. So that's essentially the point here. That's what we were trying to get at today as well.
Absolutely, yeah. How many times when you start a POC do you find out that some key assumption that you hadn't even considered is like the failure point of all your progress? And if we iterate faster, then those potentially soul-crushing moments come faster, and we don't sink more time before we reach those blockers and then have to start all over. And so essentially this idea of iterating fast and failing fast to reach success is great. And so yeah, thank you for sharing that one with us. And so when we're particularly thinking about multimodal AI, what does this look like?
Yeah. So for multimodal AI, we haven't really mentioned this yet, but now it's not just about taking an image and putting a number 0 through 9 on the image, right? Now it's going to be much more involved. Maybe you have audio, maybe you have video, and maybe also text at the same time. And somehow you need to synchronize it, figure out when this person is saying something, then it's this person in the video, and it's that region in the audio that sort of relates. And they also, by the way, relate to this text over here. So the labeling task itself might become much more complex and be much more time consuming. And of course, also all the other parts of model development that we see here on the left, they will also sort of become harder and require more effort somehow. It's no longer straightforward what should be the learning algorithm if it's a completely new domain, for instance. And I think I'm talking as an ML engineer now, right? Like you want to stay on the left side of this circle, which is all the fun stuff where you get to tweak the algorithms, you get to tune the models, you get to iterate fast, these kind of things. If you have the right side of the circle done right, so you can see here that like 50% of the time is just data labeling, data cleaning, augmentation, all these kind of things that are just they can be a bit annoying and time consuming. So really here the cycle here just needs to be as fast as you can, and so you want to turn down time consumption here as much as you can.
Yes,
because you need a lot of data. I think you mentioned that, right? But you need a lot of data. You need more data than you do for classification, for instance.
Of course, yeah, and so I think like it's funny that you make the emotional argument of like the right side of this diagram is more painful than the left, and the left is where that kind of creativity and a problem-solving approach can come in. And when we're thinking about iterating fast, right, solving the kind of brute force grunt work with automation allows us to apply the essential role of these engineers to be able to kind of harness the different models and harness the kind of conjunction of what are now often a series of operators rather than just an out-of-the-box model. It's a kind of network of these items, so allowing you to have more time to focus on that and solve these more complex problems.
Yeah, and the further you get in the process, you will also notice that it's actually not just tweaking hyperparameters. That actually ends up becoming a very small part of the development life cycle. Actually, it's the interplay between data and models that when you go back and forth, that's where you really squeeze value out of your setup. And yeah, so that's I guess another point to add here.
Yeah, absolutely. Like most of the kind of use cases that we see day to day are models that are out there in production, right? They're doing things. And so as the use case evolves and grows, it might be the assumptions you had previously or the examples that your model had seen previously won't serve it going forwards. And so you need to be able to capture more of this information and bring more of this data in. And like the way that this works is by iterating faster such that you can say, okay, as my use case is changing and evolving, the information that my system has can grow with it. And so we need to be able to set up these pipelines for kind of capturing this.
Yep.
And so Fred, like, what's the current status quo and what needs to change in order to make this multimodal approach viable?
Mm-hmm. Yeah. I think if you think about the sort of traditional way of building data sets for machine learning, you think something like this. If you look at the graph on the top, what it essentially depicts is the life cycle of a piece of data. So it will start to the left, and then it'll go to an annotation stage where a human will annotate the data somehow. If it's images, maybe it's a bounding box or a bit mask. If it's a piece of text, maybe it's typing more text, which becomes the annotation. That would be for an LLM, for instance. If it's for audio, maybe you mark a region and transcribe what's going on in that piece of audio or what's being said. Then the next stage would be this orange one where you review what you have already done. So you have a second pair of eyes, just look at it and ensure that everything is of high enough quality for you to use it for a model training. So this is sort of the very traditional way, and I think it's needless to say that this is very, very time consuming, right? Every piece of data need to be manually dealt with by at least 2 humans in this setup. And so the question is, how can we leverage all the stuff that we have at our disposition already to make this process faster? And with all these new advancements we have seen the last couple of years, obviously there's a lot of stuff we can do. Object detection is, for instance, just more or less a solved problem, at least for sort of regular objects. So if you want to do something where you are keeping track of people, you probably don't want to annotate all the people by hand. You probably want to have some sort of a data agent doing that, right? Some sort of automation that can do that in advance, and you can just fix things. If you have annotators in Europe and in the States, and some data cannot leave Europe, maybe you want to have some sort of custom routing where you put things. You don't want to have one person sitting and looking and figuring out what to send where. You just want to have things happen automatically. And so this is what we're going to try to achieve. We want to reach a state where we can do these things automatically. All the stuff that is not sort of strictly necessary to be humans, we shouldn't be doing by humans.
Yes, I like that notion of kind of solved problems and how we can like leverage these maybe unimodal solved problems in a chain in conjunction by combining their collective skills to basically create these more sort of complex workflows essentially. And so like how do we as in Encord help there?
Yeah. Well, so we have a very broad variety of customers already, and they use our platform for many different use cases. So first of all, we need to build something that was very, very flexible. And then the second thing is that we really, if you want to do truly multimodal things, then you need to do things at a pretty high scale. And so that means that we also needed to build it with scalability in mind and with ease of scalability. And then, of course, reusability is another thing. We said that you want to iterate fast, and iterating fast is not doing exactly the same process on and on. It's like doing one process and figuring out something to tweak, and then doing it again with this little tweak. And so this reusability comes in play along with flexibility in terms of being able to reuse like 90%, and then the 10% you want to tweak, you have to be able to tweak it easy. So this was sort of the goal for building this data agents library. Yeah. And now coming back to these graphs we were looking at before, where we had these red and orange nodes where humans were involved, we're now introducing these neo purple nodes. And they allow you to build these complex data pipelines that can do automatic things on your data. And all these automatic things are stuff that we mentioned already. It's like pre-labeling, it's routing based on your custom metadata or based on what's in the image. It's reasoning based on whatever model you want to use for reasoning. If you have some sort of complex decision about where should this data go, it could be, name entity recognition. It could be audio transcription. That's also more or less a solved problem. Diarization. All these kind of things are just drag and drop into your data life cycles, and then you can start automating all the stuff that should have been automated a long time ago, I guess.
And just to kind of relate this to the question that we've had from Bertil in the chat, like what's the biggest benefit and upgrade from this type of AI agenting? Like the network that we were looking at previously, which would have been kind of manually driven by humans, you can see here in this visual diagram that essentially we can leverage each of these solved problems in a series to create a more complex flow and a more complex kind of automated pipeline. And so this will reduce the latency time from moving from left to right, which was the original problem that we set out, right? How can we, as quickly as possible, get an iteration of our data labeled such that we can go through and start training a model? So when we're thinking about the data agents, what's some of the specific examples? I know you've just highlighted some on the diarization and the name density recognition, but yeah, what are some of the kind of examples that we've seen internally?
Yeah. Well, first of all, we've seen a lot of examples, and some of them are what I would call off-the-shelf examples. So, for instance, doing object detection, as we've mentioned, transcription, name entity recognition, these kind of things. Sentiment analysis is also these days more or less solved problem. And these things can just now be chained together such that you obtain the piece of information you need for your particular data. Excuse me. I wanted to just quickly get back to that question about like what are the benefits of actually using a system like this one. And I think we need to mention the fact that you could definitely build this on your own, right? You could just Hugging Face, get me an OCR model, Hugging Face, get me a sentiment analysis model, and then pipe everything together. And then you would essentially have this, right? And I would be, if I were coming from the outside, I would be like, hey, I can do that in a day. And then I have my data set. So what is this good for? And what you will very quickly realize is that you want to have like human eyes looking at it and fixing it, at least to some extent. And managing that work and moving files around on your local file systems is a pain, and it'll mess up almost guaranteed. And that's where a system like this comes in very handy, right? Where you have everything in a control setting, where everything flows nicely, and you can have keep an eye on where everything is. So I just wanted to mention that.
Absolutely. Yeah, it's a great point, and that a lot of the value add and the examples that we gave before of where our models don't understand a new situation, we need to be able to capture that additional human context and human information that our model doesn't already have. But what we can do to speed this process up is almost remove redundancy by basically filling in as much of the information as we can with the models that already work. And so that's where these different use cases, whether they be a kind of a data extraction process like OCR or NER, or a more sort of complex process like using an LLM as a judge to kind of iteratively do this yourself with these models.
Yeah. That's for sure. You want to have the humans do the things that the humans need to do, and everything else you want to automate as much as you can. Just to mention a couple of other things in terms of these data agents, what they are and what they can be. One thing I wanted to mention is that we also have a lot of customers that care a lot about security, and they also have very, very specific use cases. It could be the thing I mentioned about GDPR, right? But it could also be medical use cases where you have an expert who's very, very expensive, and you want to have him only look at the things where you're very, very uncertain. So in these situations, it makes sense to write your own custom scripts that you can inject into these data workflows or data life cycles, and have them route the data to the right place at the right point in time. So all this stuff is possible with these data agents.
Fantastic, very exciting, and I think we should start to move towards the demonstration part, right? I think we've set the scene nicely for how these can work across a range of different use cases, but today we're going to look at a specific example. So, Fred, can you talk us through what we have in store?
Yeah. Obviously we wanted to do something multimodal, and what I thought would be fun to do is actually doing two things. One thing is preparing a data set for training a video generative model. And that requires a data set where you have videos and you have some long and detailed captions about the video. So that's like one exercise, just getting that data in place, and we'll show you how to do that. And the second thing is that if you want to posture yourself for the future, then it's probably a good idea to first of all figure out which model is the better one for me to use to synthetically generate captions, for instance, or like summaries of videos in this situation. And since I'm doing all this trying to make this decision of which one is better, then I'm also already ranking my data. So that essentially gives me the ability to do RLHF later if I have to. So that's essentially the setup. We're gonna take a bunch of video clips and we're gonna pretend that we are creating music videos. I think that's a fun little exercise. So I scraped the internet for a lot of music videos and I split them into these small clips. We're gonna try to give them summaries. Did I miss anything, Oscar?
No, absolutely. I think like being able to use the different modular portions that we're about to highlight and set up in the workflow, I think all of these will come together quite nicely. So when we see a visual representation here, you can see at the top of the call, we said we were going to be leveraging all of these, we're going to be leveraging all of these foundation models for doing this kind of summarization and diarization. And so we can see here that we can capture information from a range of different sources and combine these together with our human in the loop review process as well. So I think we should definitely switch over to the live demo and get off of the slides. So Fred, do you want to jump in and and show us how this looks in practice?
Yeah. So now here we are live in the real platform, and you can see the small, I guess. Can you see these small lines? They're actually moving now, so we can see it's somewhat live. And if I go to the overview page here of my project, you'll see I've done sort of true TV kitchen style, where I've already propagated some data through my network. What we see on the x-axis here is actually all the nodes we had from the workflow. So it would start by this frame captioning thing, where we create captions once every 25 frames. And then it'll go to a human review stage. We have 9 tasks waiting for us there. And then it'll pass these frame captions through 4 different models that we hooked in, LLMs, to do this sort of video summary based on these frame captions. I have another set of reviews here, 10 tasks for me to do. And then eventually we have this data transfer that transfer the data into a sort of trainable state and then it takes things to complete. So that's the idea. Now I'm going to jump to the settings, and I'm going to put in some more data just for us to work on. So I'm going to, sorry.
Maybe before we do, Fred, could we just take another look at the workflow just from the zoomed out? I know we talked through a high level what the different pieces will do. So essentially, what's the journey that our data is going to go on once we enter it into our project?
Yeah, let me see if I can jump in a little bit here. So we have every little video clip coming in here from the start. And every time it reaches a purple node, it means that it's one of these agentic or data agent nodes. The first one is going to take the video, sample every 25 frames, once every 25 frames, a frame from the video, and it's going to ask an LLM, VLM, I guess, a multimodal LLM, to give a caption of that static image. And then because we have it every 25 frames, we get some sort of idea about what's happening across the clip. And we're going to take these frames, and I'm going to show you just in a second how it looks in the review stage. We're going to have a human review just to make sure that these frame captions are consistent. And again, this is really the power of having it in a system like this. You can actually employ humans and have them do something fast to make sure that the quality is high. Then when we have the approved captions, we are going to take all these different models, O3 Mini, Claude 3.7, Grok 3, DeepSeek. We're going to have them all produce their own summary of the video clip. And we could, of course, use them all of them essentially as a data augmentation for training the generative model, or we could just select the best one. That's what we're going to do in the review stage here. Select the best one. And then the data transfer will take this and write it into a CSV file and store the video clips ready for training.
That's awesome. And I think like that's basically the 3 stages that we saw there of using a solved problem to do the captioning, capturing our human input at both the frame and video level in our review stages, and then using another solved problem of kind of summarization, one of the strengths of these foundation models, to basically increase the captioning power of our model. So to go from just a frame level to include that temporal dimension that we get in a video as well. That's great. Thank you.
Yep. So I'm just going to quickly head over here to the settings, and then I'm going to attach some more data just for you to see it run through the. So I'm going to attach another 10 videos here. And if I come back here, you should see a bit more data coming in. And then meanwhile, it's being processed here. Let me just jump to give you an idea of what's actually going on. So now we described it before, but let's actually see here. So we had this frame captioning thing working for us, and it would produce a caption for the first frame. And we can, of course, look at that, and we can jump to the 25th frame and see how that looks. It actually accurately reads off some text from the image. Further on to 50, it also got that text right. So it seems factually correct what it's doing. I'm being a bit brief here and a bit fast, but I'm going to select them all, and I'm going to approve them. Then I'm going to approve this task. Great. So if I now come back to my overview, I should see a little task coming in here over here for GPT. And in a bit, we will see it sort of trickle through the workflow. Yeah, let's also actually have a look at the second one. Look at how it actually then looks when the data has gone through all the different LLMs. So now, oh, sorry.
No. Just to say, so where are these operations actually happening? So I can see that, we have this summarization, and then we have the review stage where we were looking, we're able to see these labels, but where's this actually happening at the moment?
Yeah, at the moment it's happening over here on my Colab notebook, actually. So you will see here, I have an agent running for the frame captioning. I have one running for the different agents, missing the DeepSeek one, by the way, because it's a bit too big to run in a Colab notebook. So I'm running it elsewhere. And then a data transfer agent in the end. So there we see here goes the execution of that the frame captioning we just appended.
Very cool.
Yeah. Okay, so I think let's just come back here and we can. I was about to say make a vote, but I think it's going to be a logistical problem for me to actually do it live. But yeah, here we can actually go ahead and actually review the summaries we got from each of the 4 models. And of course, we're going to store all of them. It would be a waste to get rid of them. But I'm going to say that the winner is, what do you think? I don't know. Maybe Claude should have a little applause there. Done. So save. And then again, approve them. And I can approve this task as well. And now we should see if I come back over here and look at all my agents here running. We'll see the data transfer. Oh, it actually went there. It picked
so
up
that
this
was my human data capture. So that was basically taking the video summaries that we generated with all of our different models, choosing our preference, and then that human data capture was selecting the best of those examples. So this is an example of using this kind of scoring function, right?
Yeah. Oh, I think something got lost here. But yes, exactly. So that was us giving that score. And we could of course use that for, as I said, RLHF, where we use it to train a value function, essentially, for a reinforcement learning post-training method. Or we could just use it to validate which one of the 4 models is best on average, and then maybe just go for that one in the future. Yeah.
Very cool.
Let's have a look over here. So now most of the frame captioning is done, and we have more tasks waiting for review here.
This is awesome. And so as we're kind of pushing these tasks through, and I think like if we look forward a few years, or maybe probably months at the rate that things are changing, right? When we have these humans going in and doing this this ranking and this scoring and aggregation as well, then it's not infeasible to think that at some point those stages could be turned into an agent too, right? This is where that flexibility and reusability of having them as an individual node becomes super powerful.
Yeah, definitely. I think one good multimodal use case is actually thinking about this model from OpenAI called Clip. It's a model that understands how to take images and text and relate them in a common embedding space. So that's inherently multimodal. And that was one success in itself, and it allowed us to do similarity search across text and images. So I can write a piece of text and I can find images that matches that text, which is remarkable on its own, right? But that model just became a stepping stone to produce diffusion models that can generate images based on text. So I think that's one really good example of where you just stand on the shoulders of like latest achievements, and then you achieve something even more impressive. And we will see that again and again. It's the same for robotics. We saw VLMs, LLMs that understand vision as well, and now we see LLMs that understand vision and can translate that into robot actions. And again, like we see these all the time, and that's really remarkable. And that's why you really need a system that is very flexible and can sort of keep up with all these advancements.
Very cool. Very cool. Thank you so much, Fred. And I think maybe before we go to general Q&A, because I can see that there are some in the chat, are there any specific questions relating to the workflow or the demo that we've just seen here? If not, then one from my side would be that how are you actually building these agents?
Yeah, that's a good question. And Oscar, I can tell you that there's a lot more reading to be done here. If you want to see this particular one we just did, there's something very, very close to it as one of our examples in the documentation. So if you go to, yes, can you see it here? agents-docs.encord.com, then you will find it. And it has a bunch of examples and tell you how to do it. Yeah. I think we'll also share it in the chat, the link. Oh, you did already.
There we
nice.
go.
Thanks.
Awesome.
Yeah.
Thank you. So now maybe on to the kind of Q&A side of things. So we've talked a lot about the positives of building these agents, but there's a question on what could the potential drawbacks be? Are there any potential drawbacks?
Yeah, I think the question also alluded a little bit to the fact that you might get some sort of inconsistency or biases you might bring along from your old model or from the model you took from Hugging Face. And that's definitely a concern. And it's also why we cannot completely automate this. If you want to have something that is specific to a particular use case, you need to run it against humans. Essentially, you need to align it with your human intent. If you don't do that, then you won't know where you end up, right? So in that sense, you need some sort of leash on the system, which is going to be the humans. So I completely agree on that concern. The question is how much faster you can go without sort of introducing too many biases. And we have definitely seen many good examples of how you can go much faster this way and still achieve way better results. Another analogy I want to draw here is if you think about LLMs and how you train, like how DeepSeek, for instance, was trained. It's essentially trained on synthetic data all the way, in the sense that you can think of reinforcement learning as just a model generating synthetic data and evaluating it, doing it again. So it's just evaluating it against these particular functions, which is extremely smart, but it's essentially equivalent to training on synthetic data. And these kind of automatic labeling, for instance, workflows are also some sort of synthetic data, I guess. So I've seen it work for other use cases.
Yeah, and I think that sort of connects to these questions around inherited errors. So if a model, if a model-ready data set is being labeled by agents, then will it inherit the errors? And that also connects to a question around other cases where the models may not be helpful and harm the data as well.
Yeah, and that's exactly why you want to do many iterations. So you want to, maybe you just do it almost head out under the arm in the beginning, and you just keep humans minimally involved. Then you start analyzing your model performance, surfacing all the model errors, and you realize, oh, there are these biases. So then the next thing you need to do is you need to go back and either fix the data set you have already or build an even bigger data set with all these edge cases covered, right? And that's exactly what we mean by continuously iterating, to actually make it do what you want it to do. Yeah.
I also think as well, the conversation we're having today is very zoomed in on the actual annotation problem, as in like capturing structured data for all of our unstructured modalities, right? But there's also the piece around curation and how we can evaluate our models across our data too, where it's like, if we are using these, if we're relying more on the models to do the actual annotation itself, then we need a way to be able to identify these outliers. So we're aware if something's on trend, then it's probably just like a capture of the model accuracy, right? But if it's an edge case and we need to investigate this, we can also select the cases where we need our human intelligence to be there to review it more wisely, essentially, so we can kind of better hone in on the correct parts of our data.
Yeah, for sure. Yeah, and we've also seen, these VLMs being, sample some of the data and run it through a VLM to just double check that everything is what you expect it to be. Write it a prompt, show it your data. Does it agree with what it sees? There are many ways of doing it and trying to improve the quality.
Yes. And there's a question about a bit that's around how easy it is to basically modify these workflows. So Fred, when you said out at the start that there's an example in the documentation for this single frame image capture, what did the process look like for adapting that and including these extra fields? Like what was your approach, and how did you kind of go about that? And for the person who asked the question, we can maybe loop back on the specific case that you have after the webinar.
So you typically what we do is we if you want to update something, you typically create a new project with a new workflow, and then there's a very easy way to sort of mirror the labels onto the new project. The stuff you have already structured, and then you can sort of improve on that on this new project. That's typically how we do it. So for the one I did with these static frames, and then further on, I knew what I wanted to do, so I set up the workflow accordingly in the beginning. But yeah.
And I know you and the team have been playing around with some sandbox examples of creating these workflows from a prompt directly, such that those layouts can actually be generated for you as well. So I know that going forwards, this is something that internally we're thinking about, and how we can streamline all of the processes around this architecture as well, so that you can spend kind of less time even configuring these in the first place.
Yeah. And I think it's a value thing to be able to dynamically update the workflows. It's definitely a valid wish to have.
Awesome.
I see there's also a question about if you have an in-house model that you want to use for pre-labeling. And we have, I think the short answer is we have tried to make it as easy as we could to actually let you as an ML engineer or ML ops person just only focus on the stuff that matters, which is actually running the model against your data. So we will help you surface the data into the, you define a function where you say, I need the frames of my video, or I need the path to where the PDF is. And then we give you that path pre-populated in the function, and the only thing you need to do is run your model. So it's supposed to be easy, and I would encourage following the documentation.
Yes, and we've now sent that through in the chat. I think the last question before we round up, I know today we've shown an example that was deployed in notebooks, but how are we seeing these agents deployed in production today?
Yep, that's a really good question. And it's something we haven't showed here because it's just not super nice to look at in demos. But when you scale this up, you typically want to have it running on multiple instances. Maybe you want to even have it run on a serverless setup. So in the documentation, you will also find how to do it with Celery, for instance, which is the queuing system. You will also find how to do it with Modal, which is the serverless system where you just define your function, and then it magically, scales into the cloud to the limit that you set. And so you can easily make it scale and run. Another thing we are looking at is how we can create webhooks for these task agents. So you don't need to have them running idle all the time. You can just have them execute whenever something is showing up in the queue.
Fantastic. Thank you so much for your time today, Fred, and thank you everyone for joining. I hope the session has been informative. Please, if you have any specific questions that relate to your use case in particular, reach out to us and somebody from the team will be in touch. And yes, thank you all again, and have a good rest of your week, and see you at the next webinar. Thanks, everyone.